So this is question 8 from 2019 paper 2, and what they're asking is about a bridge. So you'll get a wee picture of a bridge and you'll see this no doubt will be a Pythagoras part and part B, but we might as well do part A first. So this bridge has been built and the workers paint 367 lines in the centre of the road. Each line is 4 metres long and there's a gap of 2 metres between each line. So we're going to use that information to work out what's the length of the bridge. Now, so if you think about, you got these lines up here. Okay, so each line's 4 metres and then there's a gap of 2 metres. So there'll be a 4 metre and then there's a 2 metre gap and then a 4 metre and then there'll be a 2 metre gap. Then 4 metre. So we're going to essentially have to work out the total length of lines and also the total length of gaps. Now, in order to work out the total length of gaps, see if we've got 3 lines there. So there's 3 lines. That gives you 2 gaps. Okay, now if I extended this along, so let's do some more lines. Right, so there are 6 lines and then we've got 1, 2, 3, 4, 5 gaps. So the number of gaps is just 1 less than the number of lines. Okay, so we've got 367, that's the number of lines. If we times that by 4, that'll give us the total number of lines. 366 times that by 2, that'll give us the length of the gaps, and then we'll just add these together. Okay, so that's 1468, and then 366 times 2, that's 732, and we'll just add that previous number together, and that gives us, if we then add these two together, that's 2,200 metres. Okay, and that's the length of the bridge. So again, right, draw wee diagrams, that could help you out. Okay, so that's the length of lines, the length of gaps, and then you just add them together. Next one here, what you've got is you've got 2 triangles, okay, and you're going to try and work out the length of the cable. Now you've already got 300, so we're going to have to work out what's the length of this. Okay, now these are 2 right angle triangles, and straight away you'll have Pythagoras, and they've given you the formula as well, so that shouldn't be hard to remember it. But as I said, the formula's there. So let's look at this triangle. Now this triangle, just a wee sketch, we've got down here, we've got 300s and we've got 295, and we're going to try and work out the height of this, because this side is shared by the other triangle, so it's like Pythagoras through 2 stages. So what we're going to say is that, I'm just going to call it h for height. H squared is 300 squared minus 295 squared. So we'll just put this in the calculator. So that's 300 squared minus 295 squared. That's 2975. And then we're going to take the square root of that to find out what the height is. So take the square root of that. That is 54.5 metres. Okay, so that's the height of that triangle. Now if we look at this triangle, okay, so this triangle, the larger one, and again we're going to use Pythagoras, so we now know the height of that. H was 54.5, we know that that's 600, and that cable, call it C, this just so happens to be what's in the formula, and C for cable, so C squared is equal to 54.5 squared plus 600 squared. The reason why we're using minus there, or subtract, is this, if it's a shorter side, you get this long side, subtract the other shorter side. If it's a long side, you just add the two shorter sides together. Okay, so let's get this 54.5 squared plus 600 squared. Okay, so C is going to be the square root of all that, so I'm just going to take the square root, and that's 602.4, 602.4 meters. Okay, so that side is 602.4. We can then add the 300 to it. Okay, so if we then add 300 onto that, your total length is 902.4 meters. Okay, so that's the length of the total cable required for this bridge. And hopefully that's helped you.